Good day, I am Stephen Alojado, a Mechatronics Engineer graduate from Batangas State University. So today, we are on the part 2 of our Electro Pneumatics using FluidSIM tutorials. So for this video, for this tutorial, since we have already created a pneumatic diagram, we'll be creating the control diagram naman. So for this one, there are two conventions. First, the use of IEC symbols, and the second one is the use of ladder symbols. So for the ladder symbols, we use NEMA convention. So for the IEC, it looks like a ladder but in a horizontal orientation. For example, we are going to control the cylinder A, the extension and retraction of cylinder A with the use of push button. So I'll grab this push button, then grab a solenoid and name it same as the label in our 5-way valve. So it is expected that if I press this push button, let's name it PB1, it will extend the cylinder. So let's copy this one and create another for the retraction of the cylinder A. So we'll just rename this to PB2 and this also to A-. So we can actuate the retract side of the 5-way valve. So let's start the simulation. So if I press PB1, it will extend the cylinder, and when I press PB2, it will simply retract. So it's a simple control, simple manual control of the cylinder. So it's important to note that once we see a red path of this from this control diagram, so the electricity is flowing through 24 to 0, so meaning it's passing through. So whatever output is connected to it, it will energize. So thus making A+ energize and make the cylinder A extend. So when I press naman the PB2, it will retract the cylinder A. So it's important to note that we need to cut off the signal once the cylinder has already made the motion intended, because when, for example, we use a deepen switch, so deepen switch is a self-latching push button, so self-interlocking siya. So when we simulate this, when I press it, it will hold the contact from this push button down to the solenoid, and when we press PB2, that will energize A-, solenoid A-. It won't be doing anything because the solenoid A+ is still energized, so it's interfering with the process. So it's important to cut off first the signal before retracting it. So it's the basic information that you'll be needing when creating electro-pneumatic control diagrams. So there's more symbols here. So for example, general switches. When we use general switches, for example, we name it as A0. It will automatically look like a limit switch. So there's two type of switches used to determine the position of the cylinder. So from the first video, I've mentioned about the reed switch and the limit switches. So limit switches are mechanical switches that usually detects the position of the piston rod. So if the cylinder extends, it will hit the limit switch. So if it retracts, it hit the limit switch in the retract position. So there are another type of position sensing sensors So basically they are sensors. So for this one it's a magnetic proximity sensor. So simply magnetic lead switch. So sometimes magnetic lead switch only have two wires. So it functions like a push button or a switch. But sometimes or oftentimes lead switches um, have three wires. So two of those are for supplying power to the sensor. Then this terminal is responsible for sending the signal or the status of the proximity switch. So there are other types like capacitive, inductive, and optical proximity sensor. So for this demonstration sake, we'll just make use of general switches or the limit switches in creating our control diagram. So for this video, we'll be programming a simple sequence. So A plus B plus A minus B minus. As you can see, this is our sequence. So meaning cylinder A will extend, cylinder B will extend, then it will retract cylinder A, and next step is retracting the cylinder B. So it's important for us to know what input devices will actuate this movement or will make these movements. So for example, we will be, in order for us to extend cylinder A, we'll be needing to press PB1 for it to activate. Next is when cylinder A extends, it will hit A1. So we'll put A1 here, since when the cylinder A extends, it will hit A1 and it will cause to make cylinder B extend. So when cylinder B extend, it will hit B1. Then when cylinder A retracts, it will hit A0. And then lastly B0. So here is our what we call the displacement step diagram. So I forgot the exact name of this diagram because it differs with the displacement step diagram, but it is the one that we mostly use in creating a pneumatic or electro-pneumatic control diagram. So for this one, we'll be using ladder symbols. So I'll get electrical symbols. Then the first thing first, we'll need to create a initializing bang or the one that will start and stop the system. So this is equal. We'll name it R1 for the mix switch. We'll name it R1 also. So as you can see, it's a holding contact. So when I press start, it will maintain the status of the coil even if I release the start push button. Then the only thing that will make R1 coil the energized is the stop button. So after which we can link it to the solenoid A. There are two ways we can isolate the wiring of this of the solenoids. Example R1 like that. So the downside of this method is we'll be needing to use two contacts of the relay R1. So sometimes in the real world there are only 2 to 4 contacts available in our relay. So like so. So if we will be going to do this method, it will make us use more contacts in our relay. So for simplicity's sake, we'll just put this parallel to the R1. So if R1 is energized, it will also extend or energize the solenoid A+, making cylinder A extend. So after which, we know that after cylinder A extends, it will activate A1. So we'll get a make switch here and name it A1. Then we'll be linking it to our B+. Like so. So we can check if our program is correct. So the sequence is correct. A+ will extend followed by B+. So we can slow the flow of air towards our cylinder by making use of our flow control valves. So the next thing we need to do is to actuate the retraction of cylinder A by using limit switch B1. So if B1 was pressed or touched by the piston in our cylinder, we'll be using another relay here. Then R1. Let's name it to R2. So if B1 was pressed, it will energize R2 and it will A minus. It will activate A1. But as I've mentioned earlier, with cutting the continuity or cutting the electrical signal in our rank, so when we simulate this, since R1 is still holding, cylinder A won't be retracting, so we'll use an NC contact here of R2. So when R2 is energized, it will break contact here at our R1. So let's try. It break contact and cylinder A will successfully retract. Then after which, since when cylinder A retracts, it will hit A0. So it's responsible of retracting the cylinder B. So let's check A plus, B plus, A minus, B minus. But as you can see, the signal is not cut here at the part where we energize R2. So the last control element, or the last input element that is mechanically pressed, is the limit switch B0. So we'll use a brake switch here, or an NC contact of the limit switch, and name it B0. So when the cylinder B retracts, it will reset the status of R2. There. So again, A plus, B plus, A minus, then B minus. So after which we have already created the control diagram for this one. As you can see here at the bottom part, there's a signal flowing, since at default, or at the start of the process, cylinder A is in the retract position, thus making it hit A0. If we don't want for it to create or send a signal towards the B minus solenoid, we can use a normally open contact of R2 here at this point. So it won't be affecting the program too much, but it will help us not to always send a signal towards the B minus solenoid. So let's try. So we make use of an NO contact here, so it won't activate unless R2 is also, unless R2 and R2 is energized, the coil R2 is energized, and A0 is pressed here in our cylinder. So let's try. There. So after the sequence have been initialized, it won't be doing anything. So let's try again. A plus, B plus, A minus, B minus. There. So this is a simple, or the most simple sequence that we are be dealing with when creating electro-pneumatic system. So for the next video, we'll be dealing with another sequence and how can we approach it. So thank you, and good luck on your study with electro-pneumatics.